Today, we are going to have a collaborative event between NetApp, Cisco, and Force3 hosting the next generation data center and data center challenges. So more or less the data center of the future for NOAA, addressing your particular challenges. So just a couple of housekeeping issues. As you see, there's quite a few people on this today, so everybody is muted. If you have questions, please feel free to ask them within the Q&A section or the chat section, and I will moderate those for everybody during the session. After each 45-minute session today, there will be a 15-minute Q&A session. So if you have additional questions that are not answered in the chat for any reason, there will be 15 minutes of Q&A or a break. So we have 3 sessions. The first one is Journey to the Cloud. That's going to begin here at 10 o'clock, hosted by Jeff Grunwald, our very own Force3 Director of Data Center. After that, we'll go to next generation data centers and then collaboration solutions. So again, you don't have to join every session. We would love you to participate in every one or come in and out as you can. But feel free to drop off, join back in. Hopefully everybody has their DoorDash coupons and is ready to order their lunch. So with that, I am going to kick it off to our first panelist, who is Jeff Grunwald from Force3. He's going to discuss the journey to the cloud with NOAA. So from that, Jeff, I am going to turn it over to you.
Thank you very much, Jamie, and welcome everybody. You know, the breadth of what NOAA does really is amazing sometimes, and I don't think a lot of people understand what it is that NOAA does or entails. You know, everybody knows about the National Weather Service, the National Hurricane Center, especially at this time of year, but NOAA is much, much more than that. And just at this webinar today, we've got representatives from the National Severe Storms Labs. We've got National Marine Fisheries Service, the National Center for Environmental Information, National Centers for Environmental Protection, National Environmental Satellite Data and Information Service, the Radar Operations Center, National Weather Service, and several more. Personally, I'm always amazed the more I learn about NOAA. I have a neighbor who does work for NOAA, and one of the hats he wears is he's a storm chaser. He's one of those nuts who flies into hurricanes, providing safety and data for all the rest of us. And he told me at one time that NOAA Corps is actually the nation's 7th branch of the U.S. military. It's also the smallest branch of the military. Another fact that I didn't know. But no matter which part of NOAA you're with, NOAA is all about technology and data, which brings us to the cloud. I'd like to start with a brief definition evolution of what the cloud is. A number of years ago, I was talking to a senior technical executive from a large technology firm, and he was talking to me about this new concept of the cloud and what the cloud was. And we discussed it for a little bit, and I said to him, so basically, we're talking about using what you need when you need it, taking resources as you need them, and giving them up if you don't need them. And he said, yeah, that's basically what it boils down to. I said, well, it sounds a lot like TSO, or timeshare option, which was the way the computers were used at the dawn of the mainframe age. Now, I'm not saying that what was used in the 60s is cloud computing, but the concepts of using what you need as you need them have been around for a long time. The tools have gotten better, the technology has evolved, and we're now up to the point where about 15 years ago, as cloud started becoming prevalent, it was really your bits running on someone else's server. Which brings us today in a current definition that I really like from the book Building Evolutionary Architectures by Neil Ford, Rebecca Parsons, and Patrick Kua, which says that cloud is a variety of technologies that allow rapid provisioning of systems or services from a shared pool of resources. Provisioning, systems, services, and shared pools. That's what cloud is really all about. So let's start with a quick level set. You know, why should we use the cloud? Well, today, technology has reached a level that dictates the way people live their lives. For federal agency, that means embracing the advancement of technology, which includes the current trends of cloud computing. The NOAA administrator, Dr. Jacobs, says that the cloud is the future and central to NOAA's missions. One thing that's for certain, though, NOAA will use a hybrid cloud approach, if not permanently, at least for the foreseeable future. This means keeping both data handling and network availability and construct in mind. Force 3, NetApp, and Cisco provide the know-how, resources, and solutions to meet all of NOAA's needs in these areas. And while changing is hard, so is not changing. Making data accessible is one of the focuses when moving to the cloud. And according to one source, NOAA collects the second most data of any government agency. As you can see from this quote from the NOAA website, it's terabytes. And in fact, it's tens of terabytes a day from a variety and a wide range of sources. So making this data accessible to the sciences and researchers, as well as how to store and maintain it effectively, is an ongoing debate. If NOAA is going to look at the cloud as part of its strategy, it's essential to consider some of the advantages and disadvantages of cloud computing. So some of the advantages include, of course, as we started to discuss, accessibility. Accessing your data from anywhere at any time the same way. I have a relative who recently needed a new computer. Their computer was over 10 years old. It was time. And about the time that we were getting the new computer, they were having email problems. So I got the computer. I loaded it with my wife. We took it over, and they were complaining about their email. They couldn't see their email. They weren't getting all of their email. They were missing things that they know they should have been getting. And I had to explain to them that it was just coincidental, is that it was happening as they were changing laptops, because their mail application is a cloud application. The application isn't on their laptop, neither is the data. And I actually had brought my laptop to them and had them log in to show them that they could get their email from any place. This is the accessibility that we're talking about, how to get what you need wherever you are. A second advantage is flexibility. It's easy to purchase cloud services, creating flexibility to decide when to implement and where and when to increase capacity. There's the advantage of cost effectiveness, because you can now cut expenses formerly used for additional software and licensing by moving to the cloud. And the last advantage we'll discuss is maintenance. Cloud service providers do infrastructure maintenance for you. This alleviates the need for windows of downtime for offline applications and allows data and applications to be available all the time. But of course, there's always two sides to every coin, and the cloud services do come with certain drawbacks. With the rise of cloud computing, statistics have been astonishing. Some problems occur. So a couple of disadvantages are inconsistency. Poor performance on shared infrastructure can be inconsistent based on location, on speed, or other factors that are outside of your direct control. Our old friend flexibility, the advantage of being able to add capacity whenever needed, has a flip side. If agencies are not careful about giving capacity back when it's no longer needed, costs can spiral out of control. This loss of visibility is something that many organizations struggle with after moving to the cloud. Yeah, an example is an agency that a while back moved off to the cloud and saw some initial cost benefits. But after about 6 months, they realized that not only were they not saving money anymore, their environment was actually costing them more than when they were not on the cloud. And when they did an analysis, what they found was they had been provisioning more resources as they needed them, but they were never giving them back when they were done. So they continued to pay for these resources. It's said that you're paying for what you need when you need it. but what you're actually paying for is what you provisioned. Cloud providers are happy for you to pay for what you've provisioned, but are not using. So this flexibility really has to be something that's closely monitored. Another disadvantage can be privacy and security. Even though safety is at a high level with every provider nowadays, there are still concerns about data breaches. And while those concerns are real, don't be fooled that security is only the purview of the cloud provider. According to Gartner's cloud computing statistics, more than 90% of breaches are the user's fault and not the provider's. And we'll talk a little bit more about this as we move through this presentation. And finally, let's talk a little bit about data transfer costs. Monthly outbound data transfer is charged on a per gigabyte basis. The cost for data flow across the network can be surprisingly large. Now, an occasional gigabyte here and there won't make a difference, but it can still be a big mistake to replicate a frequently updated database across the country every few seconds just because you're concerned about a natural or man-made disaster. The same is valid for storing and using data. One public cloud provider has a tier designed for long-term backups that's priced very seductively at 1/10 of a cent per gigabyte, which works out to about $1 per terabyte per month. It's easy to imagine putting aside your backup tapes, your virtual tapes, and your procedures and hassles for the simplicity of this type of service. But let's say you have to access that data. The cost for that will be 2 cents per gigabyte, meaning it's 20 times more expensive to look at the data than to store it for a month. This means that you need to look at how much you're going to use the data, how often you're going to transfer the data, and how much data you need when you need it as you're moving to the cloud. So let's also take a look at a couple of myths and push them aside before we talk a little bit more about what we're going to do in the cloud. Myth one is that the cloud is always cheaper. The reality is, as I was just talking about, as part of a migration strategy, you should consider the total cost of ownership. There are many reasons to move to the cloud, including quickly deploying new capabilities to applications or elastic scaling based on demand. But for some workloads, you may not see an immediate drop in operational costs. An assessment of what to move and the order in which to move it should be done when moving to the cloud. How to migrate should also be considered, and we'll talk about that in a bit. The second myth is that all organizational data should be in the cloud and that all data processing should take place there too. The reality is there's not always enough pipe and bandwidth for all of your data to be in the cloud. Attempting to move large amounts of data from the cloud to the end user or to the edge can strangle the network. With data-intensive workloads or analysis that requires a significant amount of processing, a hybrid architecture or decentralized data processing may be a more reasonable model. An analysis at the beginning of your journey can help determine what should be moved, maybe what shouldn't be moved, and maybe where a hybrid approach can take place. The third myth is that outsourcing and cloud are the same thing. Well, the reality is, for one, outsourcing has been one of the most popular methods of cost control for federal agencies that wanted to simplify their problems of inadequate IT resources. In outsourcing, a third party will monitor, keep, and handle agency data, serving as an extension of your team and sometimes even sitting with your team. This lessens your trouble when it comes to building in-house IT skills, which can be expensive also. On the other hand, with cloud services, agencies rent prepackaged IT services from providers and then process data themselves in a self-service fashion using infrastructure and resources supplied by the provider. Users process their data while operating the provider's resources in a self-service basis. You may, and in fact, many federal agencies do at times, have very specific requirements of what you want to see in the cloud. But at the end of the day, it's still the resources of the cloud provider which need to be provisioned. This is why we say that there is sometimes a hybrid approach where you own some of the resources. Now, while cloud and outsourcing both use outsiders as part of the IT operations, the SLAs, the cost models, and the agency responsibilities are very different. They are not the same thing. Finally, every time you think about the cloud, you have to talk about security and the myth that the cloud is inherently insecure and it can't support federal government workloads or data. The reality is that while security is certainly always a concern, especially for the federal government, and while this statement may once have been true, it's simply no longer the case. There are a proliferation of industry mandated security frameworks, government standards like FedRAMP and RMF, as well as tooling and monitoring and dedicated cloud service provider enclaves. These all allow agencies to align to a broad set of data sensitivity levels, including those managed by DoD and the intelligence communities. The critical aspect of the security in cloud is the ability of everyone involved, NOAA, cloud service providers, and the integrators, to adequately delineate where responsibility lies for securing the different layers of application and infrastructure architecture. And this is what I was referring to earlier. Everybody needs to understand how to do their part in securing the entire environment. Cloud service providers are securing the equipment and access to the equipment. The integrators are working with the applications, and NOAA and other end users have the responsibility for user access and other access points that they control for security. Everyone working together is the only way to have good security in the cloud. So now that we've talked about some of the myths and some of the advantages and disadvantages, well, when you're moving to the cloud, we're talking about migration. And this continues to be the challenge in any cloud strategy, federal or not. According to a recent study of public and private sector IT leavers by Frost and Sullivan, 52% cited migrating applications or data to the cloud as a key challenge that hinders their IT initiatives. With that in mind, one thing to consider when moving to the cloud is what to move or to put in the cloud. And this is not a one-time decision, but must be part of the evaluation process every time you consider moving data or applications to the cloud. This is one of the most consistent errors that agencies make, not thinking about what they are moving. Is it going to meet their goals? Will it meet the criteria? And if it should or even can be moved to the cloud. Another of the most consistent errors you've got to look to avoid whenever you look at moving anything to the cloud, be it an application or a data set, is you always do the homework required to see if it will benefit from a move. Do not just make assumptions. Applications that have a large memory requirement, for instance, may not be good for the cloud candidate without modifications. And if you're going to move them, are the modifications worth making? There are application dependencies you might consider, particularly if an application you want to move to the cloud is dependent on an application you'll be keeping on premise. You also need to consider availability. Moving an application into the public cloud can give you greater availability, but keeping an application on site or moving it into a private cloud, you get more flexibility and control over the entire environment. You also need to consider support. What impact will moving certain applications into the cloud make on support? Have you considered any external dependencies you need for the applications? An example of that might be an application dependent on classified data source or dependent on another cloud application where availability is concerned. Reviewing the patterns of utilization as part of the evaluation process is another important factor. Understanding how your applications, systems, and servers are utilized is an essential aspect of capacity plannings. And understand your SLAs. Most include uptime guarantees, compliance considerations, data protection processes, and the process of repatriation if possible, as well as financial penalties for failing to live up to terms. One thing to not forget about addressing is scalability. Even federal agencies change dramatically in size over time, and intervals for reviewing a contract should be addressed so that your organization changes, your cloud capacity can grow or shrink with it. Finally, take a good look at that IT inventory. This is something that many people, not just federal agencies, forget about. Look at your entire infrastructure. As mentioned already, the typical initial step in a cloud migration process is the discovery of the IT portfolio. If that discovery process entails application metering, which we will discuss, to determine the actual usage of deployed applications, it's not unusual to find that anywhere between 10 and 20% of the enterprise IT estate is no longer being used. Retiring these unused applications can have a positive impact, not just with the cost savings realized by no longer maintaining the app, but by allowing outside resources to be devoted elsewhere and by minimizing security concerns for the obsolete applications. You can also find, if you have legacy applications, applications that still need to be used, some only periodically, but may not show any savings and not be candidates for being moved to the cloud. Doing a complete inventory to know what you have is exceedingly important. Another early area of consideration when moving to the cloud, whether it be your first application or your last, are data management policies. And this is specifically critical for NOAA, whose business is data. These policies ensure that the agency is appropriately managing and retaining data. The policies will remain vital as you migrate to the cloud. Some key areas to pay attention to include data creation, accessibility, retention, archiving, and deletion. You need to make sure that when you move an application to the cloud, you still comply with agency and federal data management policies. So when considering these data management policies, it's also an excellent time to talk about a strategy that includes data tiers. Tiering is twofold, and we're talking about tiering data here. What needs to be on high-speed devices? What data can be accessed a little slower? What are the archiving and backup needs? Different types of data for different types of storage. As I've already talked about, data transfer and data recovery costs are two of the factors that agencies have found which have hampered movement to the cloud. To find a happy medium between cost, convenience, and accessibility, a data tiering strategy needs to be at least considered. But with data sets and storage environments growing exponentially, there's no way that IT teams can implement data tiering manually. Automated workflows and processes are necessary in order to reap the benefits of data tiering, whose main value proposition can be summarized in CapEx, capital expenditure, and OpEx, operational expenditure. CapEx savings can be attained by extending the capacity of on-prem high-performance storage platforms. Instead of provisioning additional expensive storage arrays, offload less critical data to capacity tiers. OpEx model saving using scalable consumption-based cloud storage resources. You have cloud service providers offer tiered object storage options whose pricing varies according to the performance SLAs. So the question is, how fast do you need the data? Many tiering platforms implement storage optimization methodologies, such as data compression and deduplication, or thin provisioning that considerably lower storage footprints and costs. All of these storage efficiency features can be particularly impactful when it comes to tiering backup and archive volumes. Moving data automatically among tiers ensures that performance tiers are freed to meet their SLAs for the data that needs fastest read-write response times, and as a result, end users and applications experience significantly better performance. With cloud tiering,
Jeff, I'm going to pause you for
yes,
one
ma'am.
moment. We actually have a question. So
Great.
from the panel, we have one question that says, are the services that help me figure out data or applications should be migrated to the cloud? Who would provide that service?
So there's several ways of attaining it, and it's an interesting point. Some of it is, and we're going to talk a little bit about monitoring, analytics, and reporting. Some of it is by physically low. Jamie, can you still hear me? Because I just got a WebEx error here.
Yes, we can still hear you.
Okay, because it just popped up. Sorry. You're looking at, if you're monitoring and using the reporting and the analytics, there's also some AI tools that will help you. And it's a way of really seeing also what it is you're trying to accomplish as you go to the cloud. How are you going? What applications do you want to take? There are tools available. There are consulting services available. There's lots of people who have lots of experience with this that can help you and guide you. There are also resources available that can give you ideas of how to move to the cloud and what to take there first. And as we get towards the end of the presentation, I will be addressing a couple of tips on what you need to look at, with a preview of one of them being, it's really best as you're starting your move to the cloud, find something that can give you a very big win first off, show value to the organization. It then makes the move easier as you get into your harder and more complex applications. I hope that answers the question. If not, let's hit it again.
Jeff.
Let's hit it again as we go on. But we will be attaching and talking about some of those as we go through. And feel free to interrupt me, Jamie. Jamie, I love to have a conversation and hate dialogues.
That's what I'm good at, is interrupting, so I will continue to do so.
Thank you. With cloud tiering, there is no need, to make changes to the application layer, since the tiering occurs exclusively in the data layer. So cloud tiering works invisibly in the background and doesn't really disrupt any of your processes. As an example of this, and in practice, there's a federal civilian agency that offloads cold data. And for their purposes, that's data that hasn't been accessed in 45 days. Now, this data is automatically sent to cloud object storage until needed, in which case it's moved automatically back to the on-prem performance tier. This strategy was undertaken, and this goes to the question a little bit, after a careful analysis showed that the cold data was used so infrequently that the data transfer rates did not erase the savings provided by moving to the cloud. Again, the need to understand the data movement, the frequency, the volume, and cost when making these decisions is important when moving to the cloud. An example of this type of capability is the NetApp Cloud Tiering Service, which lets organizations extend their data center storage capabilities to the cloud with very little effort. No changes to the application layer and no changes to existing workloads or processes. NetApp has found that cloud tiering can optimize and scale AFF storage capacities by upwards of 20 times. So as we continue down the data storage path, when building a cloud storage environment, advanced data management for cloud storage is critical. Provisioning and management of storage are essential, but agencies need to keep in mind several considerations. The ability to provision all types of storage, NAS, SAN, etc. SMB, NFS, and iSCSI support, backup and recovery, DR requirements, and that includes your RPO and RTO objectives, and multi-cloud capabilities. An example of this type of data management software that delivers control, protection, and efficiency for data with the flexibility of the cloud is the NetApp Cloud Volumes ONTAP. Now, ONTAP is a cloud-based data management service built on NetApp ONTAP storage software and offers universal storage platform that addresses agency cloud data needs. So let's move to an area where governments, agencies actually have mature practices, and we were discussing it a minute ago, and that's around monitoring, reporting, and analytics. These operational practices need to be maintained and augmented when moving to a cloud to avoid waste, and this type of waste was identified in a Stanford University study done by researcher Dr. Jonathan Koomey. And Dr. Koomey found that more than 80% of in-house data centers have more server capacity than is necessary. Since many agencies don't do routine checks to see how much capacity they're using, they end up paying, not in the cloud, for extra electricity, cooling, licensing, maintenance, and server capacity that never gets used. This is in conjunction with what I was discussing earlier about doing an IT inventory. If you have applications that can be retired, that means you can also retire or repurpose some of that capacity, whether or not you move it to the cloud. It also has to do with right sizing the environment. When you're moving to the cloud, the extra cost rolls with it if you're not careful. Dr. Koomey estimated that users were paying 36% more for cloud services than they needed. Now, if you use an estimate that storage costs in 2018 were $173 billion, that equates to potential savings of $62 billion in IT costs just by optimizing, analyzing, and looking at your workloads. Now, the only way to identify the areas for potential savings in the cloud environment is by monitoring and analyzing processing and storage environments. These tools can leverage AI and other analytic approaches, and agencies can make data-driven decisions on how to gain efficiencies in their operations. Data-driven is the key. Let's not guess about it. Let's monitor, examine, and let the data help us make our decisions. This also goes back to the question earlier, how do I know what to move? As you look at what's being used, how often things are being used, what your data transfer rates are, what your different environments look like. And we're going to talk about multi-cloud and using hybrid environments. The data helps make the decisions for you. The goal is to identify the I/O patterns, evaluate application performance, identify policy compliance, and support capacity management and infrastructure resilience by focusing on analysis of data that are associated with IT infrastructure. This can be done and should be done for both on-premise and cloud resources. In other words, with everything you use to support your mission. Note that when I say cloud, I'm also referring to multi-cloud. It's a fact that you will be using more than one vendor, provider, or application set. It's therefore essential to do this management of IT resources holistically and consistently, which means choosing tools that support the entire environment. The type of resource data to look at includes inventory data, which can answer questions about inventory resources like hosts, storage systems, switches, disks, tapes, virtual machines, and servers. And this allows insight into replication, data paths, and potential violations. Look at performance data, which deals with performance for volumes, applications, internal volumes, switches, applications, VMs, hosts, and application nodes. Looking at your communications background. Port capacity is very important to understand switch port connectivity, port status, and port speed over time. We'll talk a little bit about how we can determine these are some of the things that we don't always see when we have problems, and monitoring and continuing to understand how your applications operate in a normal environment can help when you have problems. Chargeback data models can answer questions about used capacity and allocated capacity on storage resources as well. The ability to examine storage capacity chargeback and accountability information by hosts, applications, and projects and other entities provide valuable insights. Now, while NOAA may not use this chargeback info traditionally, i.e., charging people for what they're using, it can be very useful for budgetary processes. Now, at the end of the day, we refer to these as monitoring tools, but they serve multiple purposes. Of course, the first is the traditional monitoring to provide end-to-end visibility. The second is to aid in troubleshooting by providing insight to determine root cause analysis and reduce mean time to repair. This brings us to a scenario that many people in IT have been involved with at one point in time or another, and that's the finger pointing scenario. There's a problem. So there's a giant, it could be a meeting if we're all on site. In this day and age, it's probably a conference call where all the people involved or all the organizations involved on the phone are on the phone. You have your data people, you have your communications people, you've got your storage people, you got your virtual machine people, you've got your operations people, and they're all looking at reams of data. And they're looking at their environment saying, oh, it looks normal. Mine looks good. Yes, I'm not seeing an error here. What we don't have is we don't have a way of cutting through and across some of these silos. We need our tools that can see the spikes as compared to normal and then determine where the best place to start looking for the problem or the root cause is. These tools allow for informed decisions to be made to help resize and reclaim resources to optimize IT spend. We can use them to provide a level of detailed reporting to help justify resource decisions and align IT costs. This reporting can be used to provide valuable usage information that can help inform decisions about moving data and applications to the cloud and how they might perform in that environment. There's a use case of an agency that does their mission is gathering data and doing very monthly and very frequent reporting on very specific statistics and areas. And when they are doing their month end and before they announce to the public all their findings, they ramp up, and their maximum size for their environments, all their VMs, and they have many of them, is about 8 gigabytes of memory per VM. And they use that maximum sizing about twice a month. The rest of the month, they're using 4 gigabytes of memory to do their normal processing. Well, when they moved to the cloud, they moved the maximum capacity with them. So in the end, they provisioned more than 2 times what they needed most of the month. They took this sizing to the cloud, and after a significant amount of time running in the cloud, they started running monitoring and reporting tools and found this out. They wasted a lot of money by over provisioning. If they had used the tools and looked at the environment as they were making the decisions, they would have saved significant money from the outset. That's why you move applications, whether it's to the cloud or not. Don't forget about the things you do well. What are your processes and procedures? What are your monitoring and reporting standards? How can you improve them? You implement these from the start. This way, you get savings and insight from the beginning rather than waiting over time. And an interesting example of this is the type of thing I'm talking about. This specifically is a storage capacity report from NetApp On-Site Command Insight. And you can see that it shows data about total capacity, used, provisioned, and available capacity. And it then breaks it out by vendor, by tier, by cost, by business unit or project, and shows some forecast information. Reports like this can answer questions about storage capacity, file system utilization, internal volume capacity, port capacity, and virtual machines. They can be used to provide insight for storage capacity resource planning and include storage and storage pools by showing capacity on the floor and in the cloud, as well as the capacity use of storage pools over time. In the budgeting process, we make assumptions. Now we can use the data to help with making decisions about moving resources and deploying resources. As we know, in these tight times of tight budgets, the more you can use data to highlight what, when, and where you need these resources, the better you can perform your mission. And once you complete this analysis and have an understanding of all the requirements for your application data, you're ready to begin the move, how do you go about it? Well, there are several methodologies, including lift and shift and re-architecting for migrating to the cloud, but one thing is clear. This is a process that does not happen overnight. Now, lift and shift provides the benefit of speed, while re-architecting provides the ability to more completely take advantage of the cloud environment and is built-in capabilities. No matter which you choose, or if you choose another methodology, it's a process that should not be rushed. I recommend including a bridge to cloud approach where risk is reduced by first migrating to an on-prem private cloud. This approach provides you the ability to test and develop processes in an environment where you still directly control all of the components. You don't know what you don't know, but if you have control over all of the components, it's easier to figure out how everything fits together. Bridge to Cloud also provides the ability to start monitoring and determining both the characteristics and reporting needs for new workflows. This reporting can be used to provide valuable usage information that can help inform decisions about moving data and applications to the cloud and how they might perform, which can help avoid surprises after the final deployment. So as we start to wrap up a little bit, there are multiple examples, and we've all seen them, of successful and unsuccessful cloud migrations that can highlight some critical aspects of how government agencies can get started in the journey. One of the biggest mistakes that have been made by federal agencies in their cloud journey is project scope. This is what I was referring to earlier. It's important to start with a small, digestible plan. And if you can't manage that, then you need to split your proposed cloud journey into several small, reachable phases. Since you don't have to move the entire data center to the cloud, it's best to break down so you'll be able to handle the inevitable rollbacks, including some that are unique to government agencies. So given those considerations, you'll want to set up a master plan that touches on starting by identifying what the agency needs are. What do you hope to accomplish, and how does that help the mission of the agency? Making sure
Jeff,
that
if we help, sorry. We have a question, so I thought we were pausing for a second, but if you want to continue and then we can go on with the question.
I'll tell you what, let's go ahead and take the question. Questions are more important than my blathering on.
It's a good, it's a good one. Can you repeat the cost for the data storage restore cost and how these were determined? Do you have any comparison for on-prem costs for storage data and restore?
So the storage. So let's try and recap the question here. Do we have any statistics for doing storage data and restore? And can I repeat the statistics that I had? Is that it?
Do you have a comparison for on-prem costs for data storage and restore?
Okay, a comparison for on data. Okay. So there are, I don't have it, I don't have the actual numbers right off the top of my head, because they as with any environment, they will flux based on what your actual need is. One of the things to consider specifically is the volume of data you're storing versus what you're restoring and how often you're going to restore it. Because it's cheaper it is much cheaper to store than it is to bring back. So you have to think about what you're leaving there. things that you're accessing frequently, you probably want to leave there because you're using it a lot and you can actually have and expand what you need. The problem that you run into, where the compare comes in, is not only the cost of the storage on-prem, but also the cost of maintaining that service, which is both a physical and a personnel cost. There are studies that have looked at that. We can actually go and research the data and find it specifically and get it back to, if Jamie, if you can get some if you can get if you have the contact information, we can go find the specific data, but it's really based on usage patterns and, things like, if you're in New York City, it's a lot more expensive to do it on site because of the actual cost of the space where your data center is. As opposed to if you're in Boise, Idaho, it's less expensive because there is, the cost of the space is actually less. There are a lot of DR centers in the Midwest specifically for this reason. And where the comparison comes in is most of the IT organizations are in high rental districts, whereas if you put stuff out into the lower cost areas, you can actually save money. And that's one of the things that cloud takes advantage of.
Thank you very much, Chris. I think let me know when you're ready and we can unmute everybody that's on the call, and that way we can get ready for a Q&A session because we are running into that time frame.
We are, and I'm about less than a minute away from being done, I think.
Okay. Thank you.
Absolutely. A great question, Chris. Thank you. We talked about, starting with identifying needs and making sure that the system is secure. You need, considerations when you're setting up your plan. Please plan on monitoring, implementing change management and support. You can't go without it. Make a repeatable plan for moving to the cloud. So as you move more of your applications and data, everybody knows what to expect and you get better at it. In the end, the tricky problem with it is that cloud's best feature, its seemingly infinite ability to scale up and handle any demand, is also a budgetary minefield. The old solution of buying a fixed number of servers for a project may start to get a little bit tight when demand spikes, but at least the budget costs don't skyrocket. The fans on the servers may whine from the load a little bit. The users may grouse about the slow response, but you're not going to get a panic call from somebody who says the oversight committee is looking at why we're blowing the budget out. So with that, knowing we're running a little bit short on time, I will stop and say thank you very much. I hope you found something of use in this, and I am going to stick around for a while to answer, like I would at any conference, any questions that anybody has. So thanks everybody very much for your time.
Thank you, Jeff, and definitely in the new virtual world that we're living now, this is a unique time. So everybody, please feel free to be very interactive. At this time, we're going to unmute everybody on the line. You can opt to mute yourself so that we can hear everybody present that is asking questions as well. If not, our next session will start at 11 o'clock. So with that, I'm turning it over to the audience. You are all officially unmuted. So ask away. And if you are too shy to ask, always feel free to use the Q&A button here on the left side or right side of your screen, depending on what portion of your browser you're using.
And while we're waiting, please enjoy this lovely melody of sea chanties. We talked about having some background music, Jamie. I didn't think
We did. So, thank you for whomever is providing the lovely whistling. Thank you.
That was crazy.
Please stick around for the next.
know these parts. Yeah, I know these parts.
All right, I think that if there aren't any immediate questions for Jeff, probably best to put everybody back on mute. And then we can transition into our next session here in about 10 minutes.
Great. Thank you, everybody, for participating. We are going to take a 10-minute break. The next session for Next Gen Data Center will start at 11 o'clock sharp. So take a break, get a cup of coffee, get some questions together. If you do have questions in regards to the Journey to the Cloud session and they haven't been answered, make sure you put them in the Q&A or send us an email. I'm happy to take any calls after this as well. We can have a further discussion one-on-one. So far, thank you, everybody, for participating. We'll be back shortly.